Welcome to our general mathematics class, and for this video, we're going to introduce the concept of composition of functions. So let us define first what composition of function is, or composite function. Given the two functions f and g, the composite function, denoted by symbol f circle g, is defined by f circle g of x equals f of g of x. So what does it mean? So let us provide an illustration for us to understand the concept of the composite function. Let's say we draw a closed curve labeled as color pink for some purpose, and it contains an element which we will call as a variable x. And now let us put another closed curve or closed region on this position. Now the job of this element is to travel on this location, and once it arrives in this position, this will turn into g of x. And take note and bear in mind that this region is what you call the domain of g. What I'm trying to imply is that this region obtaining some resources from this region in order to produce or to generate the g of x. That's why this is your domain, or this is the domain of g. Well, on that case, it tells us that this region now is your range, or the range of g. So let us have another closed region labeled as blue, once again for some purpose. So at this time, g of x is the one who will now travel on this position, and when the time it arrives on the blue region, this will now called as f of g of x. So in order for us to generate f of g of x, we must correspond some element from here, which is g of x, to here. That's why this region is what we call the domain of f, and it implies that this will be the range of f. And that entire procedure is equivalent to f circle g. And that is how composition of function works. Let us provide some good examples of composition of functions in real life. Let's say I will produce a grade of a student through her Google Classroom, and we have some outputs, 8 outputs actually. So we will label this as from x sub 1 to x sub 8. Now let's say this values represents the single x, and this single x will now travel into another dimension, which is the class record. Class record is the range of your function now, and the domain is the Google Classroom. So whatever the value of the numbers inside the class record, that will serve as your g of x. And the values computed from the class record will represent the f of g of x, which will insert in our new world, which is the report card. So now f of g of x is an element inside the report card, and domain is your class record at this moment. So the entire procedure is the concept of your f circle g. This tells us that once you compute some grade of a student, and we are doing a composition of function. So when you encounter f circle g of x, that means that we have to follow some hierarchy. So for you to produce g of x, we must have x. And for you to produce f of g of x, we must have g of x. So x will evolve into g of x, and g of x will turn into f of g of x, and that is f circle g of x. Another example, let's say you go to the market to cook a sisig, a pork sisig specifically, and then you bought some ingredients or recipes. Let's say we have a pork, egg, onion, at saka siling labuyo. Now, you put those objects inside a plastic bag. Okay. So each element will serve as your x. Now, the plastic bag will represent the domain. So this x will go to our pan for us to have the sisig or the pork sisig. The pork sisig itself is what you call the g of x, and the range is the pan. Now, hindi naman sa lahat ng oras nandyan lang sa pan yung sisig, so we have to transfer this into a sizzling plate. Now, the sizzling plate is now the range, and the pan is the domain. Inside the range, we have the f of g of x, which is the homemade sisig that we produce. So, f circle g at this moment tells us how to cook a specific food, which is the pork sisig. Now, let us proceed to some computations. Example, suppose we have some functions, f of x, 3x plus 4, g of x, 2x. And let us find the following. Let us start the letter A. We have f circle g of x. So as a solution, this is equal, so by its definition, this is just equal to f of g of x. Take a look at this. We have g of x, which is equal to 2x. So, g of x inside of the parenthesis will replace as 2x. 2x is now the input inside the f. So, let us have the function f, which is 3x plus 4, labeled as blue. Let us insert 2x inside the variable or inside the parenthesis of the function f. So, we will have 3 times 2x plus 1. So, all we have to do is to simplify. We have 6x plus 1, and this will serve as your final answer. For letter B, we have g circle f of x, and from its definition, since g is the first letter on this part, followed by f, we will have g of f of x. F of x is 3x plus 4, so we will substitute 3x plus 4 on this part. Next is to evaluate g of 3x plus 4. By doing that, let's have g as a purple. Now, g is 2x, but our input is 3x plus 4. That is why we have 2 times the quantity of 3x plus 4. Now, let's have distributive property. So, we have 2 times 3, which is 6x. Then, 2 times positive 4 is positive 8. That is why we have 6x plus 8 as our final answer. Now, let's have letter D, which is g circle g of x. This is equal to g of x. But take note that g of x is just equal to 2x, so we will label this as purple. Now observe that we have, once again, a g on this part. And since g was labeled as purple, so we will label this as purple as well. G is equal to 2x. So we have 2 times some quantity, which is x. But the input is 2x, so we have to replace x as 2x. So this will disregard. Now, this turns out that 2 times 2x is just equal to 4x, and this is our final answer. And now, letter C will left as an exercise for you to practice this concept. Let's have another example. Consider if the functions g of x, which is 2x minus 7, and h of x equals x plus 7 all over 2. Find the following. Let us start on letter A. G circle h of x. From definition, we have g of h of x. Now, observe that h of x is x plus 7 all over 2. So, this part will replace as quantity x plus 7 all over 2. Next, x plus 7 all over 2 is the input for the function g, but g is 2x minus 7. So, as a 2x minus 7, we will replace this variable as our input. We will have 2 times the quantity of x plus 7 all over 2. Of course, we have a minus 7. This part will turn into a cancellation. So, we have a remaining terms, x plus 7 and negative 7. Obviously, 7 minus 7 is 0. So, the final answer is x. For letter B, we have h circle g of x. And this is equal to h of g of x. Take note that g of x is 2x minus 7. So, we will replace this as 2x minus 7. But, h now is x plus 7 all over 2. So, we will use this function with an input of 2x minus 7. That's why we have this term, quantity 2x minus 7 plus 7 all over 2. Let us now simplify the numerator. So, negative 7 plus 7 will become 0. And 2x all over 2 is the remaining term. 2 will cancel, obviously. And the desired answer for here, h circle g of x, is x. Now, observe that g circle h and h circle g has the same answer. It was accidentally happened, classmates. But in general, composition of function is not commutative. If we look to our previous example, f circle g is not equal to g circle f, since f circle g is equal to 6x plus 1, while g circle f is just 6x plus 8. So, it's not commutative. That's all for today. Thank you so much for watching this video. I hope you learned, classmates. See you next time. Bye-bye.